Hi, I'm Guillaume LaGaillarde, owner of 1.2, a French company specialized in simulation and crowd movement. I'm the boss. This is why I'm under spotlight today. But the real guy who suffered and had the job done is Antoine Outerley. Soldiers, cheerleaders, queers at gay pride, hungry workers, peaceful ecologists, Democrats, Republicans, all of us, each of us, can one day or another be involved in a parade. Parades can be more or less organized. They can range from small groups to massive crowds. But one thing is sure, we do not walk, we do not behave the same when we are in a parade than in everyday life. Working for the Olympics over the past 3 years, preparing opening parades using Pathfinder simulation software, we had to face many aspects of parade problematics. Multi-agent-based software tend to consider crowds as the sum of individuals interacting with each other. And in fact, it is true. We all are individuals. But in a parade, we are doing much more than just walking from point A to point B. And this is the first paradox we had to face. The more disciplined your parade has to be, the more difficult it is to simulate it. And why? Because you want those teeny guys to do exactly what our director wants. So, let's explore specificities of Paris Paralympic opening parade. For the first time in Olympic history, opening parade is not in a stadium, but in the city. And believe me, it makes a huge difference. Stadiums are parade friendly. They have bus entrance, they have plenty of room under bleachers, and are designed to welcome athletes, public, and TV operators. Streets of Paris, on the contrary, do not have toilets, bus drop-off facilities, and no wheelchair-friendly surfaces. But Paris est magique. Paris offers such incredible Instagram views, and believe me, sponsors, they love it. This is a bird's eye view of our playground, and what you have seen on TV, it's only the tip of the iceberg. What you have seen on TV is just there, Place de la Concorde. Our playground is more than 1 mile long. We have more than 5,000 athletes and staff. 20% of them are on wheelchair. Some people have no arm, no legs. You have blind people, sometimes with dogs. We are talking about 169 countries, more than 100 languages. They arrive by bus. They have to rest, to socialize with each other. They are not prisoners. You know, these girls from China, she may want to meet again this athlete from Brazil she met 4 years ago in Japan. How can we make this happen? This is why we have those waiting areas, these preparation areas. We are talking about more than 100 buses, 3 drop-off zones in 3 different streets. Some people will be jet-lagged. They are happy to parade on Les Champs-Élysées, of course, but are they happy to have to wait in open air 2 hours before broadcasted show? How to make it comfortable, and of course, how can we simulate this? This is why it is important to script the behaviors. Remember, we have 169 delegations, which size can vary from 3 people from the Fiji Islands to more than 200 from the United States. And they have to be sorted in alphabetical order. You have to follow a strict protocol. This is why, after having set up a simple model in Pathfinder, we felt this need to use Excel and Power Query to fully script the model. And this is something we loved in Pathfinder, this possibility to script about everything, and especially targets. Targets are a key point in our simulations. And as we start greenfield, inputs, our director IDs, they change very frequently. More than what we can stand sometimes. and everybody wants to see it in 3D and make sure it can work. Because there is one thing we have to remember, it is that simulation models, they have to be an helping tool. Parade simulation is the center of attention of the whole team. Any idea, any teeny modification has to be tested and validated in simulation. Again, having Excel Power Query macros that will build our .bat file is crucial for us, and for sure, this possibility is what made the project possible. You can see here a simulation of what happens before broadcast parade, how athletes and staff are welcome and how they go to preparation areas. Here you have the drop-off zones. Where all the color is mixed is the waiting and socialize area, where your Chinese girl will meet this Brazilian athlete she met in Japan 4 years ago. The preparation zone, and you can notice also how different in size are the different delegations. You have these huge delegations, which sometimes are followed by very teeny one of something like 3 or 4 or maybe 10 people. And everything has to be organized so that it runs smoothly and so that athletes do not wait too long before parade. So, if we want to summarize the challenges and the risks for the organizer, first, they want to make sure that the waiting areas are well organized and capable of managing the crowd. They really want to manage transitions. They want to plan and coordinate the movement of participants between waiting zones and preparation areas, and they want to avoid congestion and to ensure smooth transitions. And also, just remember that everything is broadcasted. Behind that, you have sponsors, you have TV show. So you want to adhere to the planned schedule, you want to prevent delay, and you want to maintain order throughout the event. And something also I haven't said is that even after the parade, there are something to manage. You want that these athletes go back to Olympic Village. And remember, they are not actors, they are athletes. Some of them have a competition the next morning, so they don't want to be at the village at 1 or 2 a.m. waiting for the bus. And here we are on the day. Few days before the parade, unfortunately, I broke my Achilles tendon. This is why I wasn't there, and this is also why I can be with you today. But I was watching it on TV. We had this text to exchange with my customer. She was just saying me that everything is going smoothly so far. Believe me, that was among the longest hours in my life. And I'm looking at TV and something magical happens. The magic is that reality is exactly how it was supposed to be. Even today, I'm not sure I didn't dream this situation. But I was just watching it on TV and I was remembering the simulations, and everything happened exactly the same, or almost exactly the same, to be frank. This is another view where the first delegation are circling around the place de la Concorde and taking place into the different stands. One thing we had problems with in simulation was about turns and trying to find ways so that athletes and staff use the whole width of the alley. And what you see here is also the result of long volunteer briefing and teeny marks and lines painted on the floor. And the simulation helped us to place these marks and to brief the volunteers so that so that people won't stay at the interior of the turn and occupy the whole width of the alley. Here you can see that we use doors. They are slightly inclined towards the outside of the turn, and it helps a lot the agent to stay at the exterior of the turn. And we also use those fake huge and large agent to separate the different delegations. Just enjoy, because it took us so long to get this result. And here we are. Here you can see this alley in the simulation where people go to the different seats, and what we found in simulation is that this alley was slightly too narrow, and we are very happy to see that in reality they took this into account and made a larger alley in the real show. And here you are. This is United States. You're just before France. France is last, and just before France there is United States here, and they will have to go all the way around the Place de la Concorde. You can see how it looks very similar in the model and in reality, especially also the size of the group and the distance between the different occupants of the group is very, very close in reality and in the simulation. The last delegation, France, is taking its place around here in the stands. You can see it's very similar in simulation, the size of the group, which is here, and also here in red you have the United States, who were just here, and it's on time. It's very, very close in simulation and in reality in terms of scheduling. Okay, to conclude, in reality a real parade lasted about 13 minutes more than in our simulations, but on a 3 hours period. And what we didn't took into account is that there were some cameras where people would take selfies. We did not take into account in the simulation. One thing I will remember from these 3 years is that any difficulty you will face in simulation, it has to be considered as something you have to anticipate and solve in the real world. What I have understood is that if it's difficult in simulation, it means it indicates you that you will have a problem in reality. And this is exactly what happened. Any difficulties we have found in simulation leaded us to meetings and ways to find solution in reality. And if I wanted to give you a message also is that, of course, crowds can be hungry, they can be dangerous, and it can be frightening. But I have also learned that crowds can also mean brotherhood, good vibes, and cooperation. And I really hope to see you in LA in 2028, maybe on Venice Beach. Thanks for your attention.
Well, thank you for the presentation. We have a couple of questions, hopefully here. I have the first one from an online participant. It says, how did you model disabilities in Pathfinder? Did the model allow for vision impaired athletes, and what type of disability was the most difficult to model?
Okay, so mostly the only impaired disability we have modeled was people on wheelchairs.
Wheelchair.
So, and Pathfinder is well done for that. So we had those people in wheelchair. People without visibility, in fact, they have guides or dogs and they are in the middle of the group. So we did not took that much into account. But yes, the most difficult was wheelchairs because vehicles they don't move exactly like circles, and also what you don't see in this model is that there was also all the buses logistic, and in a bus you don't have that much room for impaired people and for wheelchairs. So sometimes you have to make sure that the guys on wheelchair we get in the right bus and that you won't have too much wheelchair people in one bus. Mm-hmm. So yeah, but mostly there were people walking and people on wheelchairs.
Okay, and those were represented in the model with the polygonal occupant using the wheelchair.
Exactly.
So you were able to represent that space, that shape. Okay.
Exactly. Yes.
Questions in the room? Here?
Yes, Kevin, just a second. How did you decide on the average walking speed?
That's a very good question indeed, because we did not. It's the art director who decided on the walking speed, and he said, "I want them to walk at this speed." And frankly, initially, they decided on a speed that seemed very, very low to us. And we showed them the first speed they wanted to use was 0.6 meter per second, which is very, very slow. But they wanted to have this broadcast show last longer. And the very first simulation we did, something like 2 years ago, was showing them how does it feel to have people walking at 0.6 or 0.7 meter per second. And once they have seen that, they agreed to let us decide what would be the right speed. And then we say to them, okay, use 0.9 or 1 meter per second. It's slow enough. And also, you will be able to have people walking at this speed. If you ask too slow, you won't make it. People won't accept to walk too slow. So the speed we finally used was 0.9 meter per second. It was sort of a compromise between what the art director wanted and between what we thought it was possible. And finally, I have to say that we could have been slower. And because at the end, when I look at reality, I see that the total show lasted something like 10% more than what we had in simulation. And we measured on TV that they finally worked slightly slower than what we imagined at the very beginning.
That's interesting. So guided by the art director of what they wanted for the broadcast was sort of the primary driver for the walking speeds. That's interesting.
Yeah, this was one of the difficulties of this project because it's simulation, but also people are guided. And there's a balance to find between what will happen and what you want to happen.
Mm-hmm. Yeah, so it's nice you could sort of pre-run, okay, if everybody walks at 0.6, the broadcast needs to be this many minutes long. If it's 0.9, then it's this. You could tune the speed to fit the time slot of the broadcast.
And also it's difficult to imagine they are not soldiers and not dancers. They are free people, they are athletes. So you cannot also ask them to do exactly what you want.
Right, right. Interesting. And you said it was about 10% longer because they were just a little bit slower than the 0.9 in reality.
Yes, and also I don't think they were that much slower, but they stopped more than what we thought.
Oh, I see.
Because they take selfies, they say hello to people and so on, and we took that into account, but not as much as we should have.
Okay, that's interesting. Anyone else in the room? In the back here?
So I saw the wide occupants in the parade there. What problem were you trying to solve with those? And how did that solution come up? For the wide and narrow occupants between the groups?
Oh, why did you use the wide agents to control sort of each segment? Yeah.
It's because we had this need to keep each delegation apart from each other because for the broadcast show, and for other reasons they don't want that the different countries mix with each other. And we had a lot of difficulties to keep the different delegations really separated from each other, and also to avoid that they would be that they would make a line instead of a potato. I want them to work as a sort of potato shape and not in line. And if I make this very large fake agent, and I say to the delegation which is after, okay, follow this large guy, they arrange better, and they are not following each other in a line, and they are more like a potato shape. And also, as they cannot overpass this bar, they won't get mixed with the next one.
So it's really separating
those. A sort of trick. It was a sort of trick. We tried many different things like social distance, etc. And the thing that worked best was this for us.
Yeah,
but it's interesting. Also, other project I'm using a lot. Sometimes those fake agents, and I put them invisible for for the end result.
Yes, Guillaume, this is Brian from Thunderhead here. Yeah, I think in lieu of a better grouping model that we'll probably never create that says, be in parade formation, your approach was a clever solution to get what you wanted. Because as you kind of mentioned, this isn't purely a simulation to predict what will happen. It's partly a modeling of what you were already expecting to happen, but just to check for, larger.
Yeah, this is a paradox of this simulation, because it's not exact. It's part of simulation. It's hybrid. It's a simulation, but it's also, okay, let's make them do what you want them to do.
Right.
So it's a hybrid. Yeah.
Any other questions here from the room?
It was actually, it was kind of interesting to discover that when you use a wider agent, that the agents who follow the agent actually spread out to follow a wider agent. I would have assumed that it would still be a sort of a center point, but it ends up being like anywhere behind the agent of its width seems to be fine. So it was kind of a discovery I hadn't considered before. I don't think we tested wide, narrow agents as like a flow control or anything. So it was very kind of inventive. There was another question online. There's actually two. One was, were you provided with the numbers and the disabilities before the simulation, or was it up to your own assumptions or previous data? How did you know how many wheelchairs you needed, or?
Yes, but it was a crucial question for us, because we were provided with a number or with a percentage of disabled people, but this evolved all along the project. And even the day before the ceremony, we did not have the exact number, because people just, each country says, okay, I will send you 20 people, 30 of them will be on wheelchair, and the rest will be on his legs. But it can change every day, and it's up to the athletes to come or not, because some are jet lagged, and some also, they have a competition on the early morning, the next morning. So some may say, okay, I will come, and at the last moment, or maybe one day before, say, oh no, I need to rest, and I won't come. So also this simulation was a way for us to negotiate with the different delegations to say, initially they wanted the Olympics wanted to have 7,000 athletes and staff, and we did not find any solution to store 7,000 athletes and staff on the room we had. So it was also a tool for us to negotiate with the different organizations. Say, okay, send slightly less people, and to open more or less seats, and also to ask to the Paris City more room. But yes, we had precise data, but they were changing every month.
Okay. And there is another question, but I'll just answer it. It says Pathfinder simulation limit is 60 minutes only. How can you simulate such a large parade? And actually, there's no time limit for 60 minutes. That's just the default timeout. So you can change that end time to be whatever you want. There's not a limit. So, okay.
But calculation time is important, because It's not only the number of people, it's also the size of the space you are simulating. It's more than 1 mile long. And I have noticed that the larger the geometry is and the longer it takes to calculate.
Yeah. Okay, well, good. I think with that, I don't see anything else in the room. So thank you for tuning in live.
Thanks a lot, and I'm very sorry not to be with you. I wish I was with you.
Yeah,
already.
we wish you were here too. Thank you. And we'll look forward to your paper and presentation later. So thanks so much. Have a good evening.
Thanks a lot. Bye-bye. Thanks.